So this discussion came out of a meeting I had with, well, a couple of us had together with some build team, with the automated build teams, and we were talking about CI/CD, and what really kind of came out of it was that machine learning is not traditional software development, right? So we have a lot of governance and rules and design. We've spent like the last 30 years trying to understand. I put 20 here, but really it's been a long time. And really the improvement in the last 20 years has been kind of this continuous improvement and now continuous deployment, but really continuous integration, continuous improvement. And it turns out machine learning and the build and train environment and the way, if you think of machine models as software, building the machine model, which is still software, it's a fundamentally different beast. And so the way we build it and kind of the pipelining that's got to be done around it feels like it is different than the traditional model. I broke these out, but some people are really opposed to that. So one part of this is feature development. So features are data sets that have been massaged or transformed in a way to be directly consumable by models and to be used as training data by models. So there's like the feature part that is fed to the model along with new inputs, and then there's like all the feature data that you use to train a model. So what happens is humans, data scientists, sit in the loop playing with that feature data, and that data could be very large and it could take a while to transform. And so they'll play with that, transforming it, including doing things like binning, right? Like, is this a large t-shirt or a medium t-shirt or a small t-shirt? 40 through 42 are mediums or larges, I can't remember which. And then so you have this feature binning and feature training and all that kind of feature development, feature creation. And while you circle on that for a little while, then you take that and you feed it to the model for training. And so you use production data to feed to a model, and then you tell it what you want the results to be. And you basically, in the model training part, you change the parameters. So there's the input data, and then there's hyperparameters. So all machine learning is, for a lot of things, is just curve fitting, fancy curve fitting. And so you know what you want the output to be because you have production data that had the right result, and you know what the inputs are. Can you train something to come up with the right answers, the same answers that you like what you have in prod? Or if you want the answers to be different from what you have in prod, you change the data, and then you do curve fitting around the results you want. So sometimes you'll sit in that model training thing, and that can take a long time. I'll talk about it later. And then if you like the results, you'll push that out to prod, right? But it may turn out that you don't like the results of that, and the features didn't give you enough detailed information or enough correlatory feature or data points so that you could actually train the model well. So you might actually go back from the model training area back to feature development, or you may go to prod, and then over time the data changes, right? So like buying patterns. You could be like, hey, we're looking for fraud. And then it turns out COVID happens and nobody's buying anything in restaurants in person except for delivery. And so now delivery can't be rated as a more fraud thing. I made that up. I'm sure it's not. Because now the delivery numbers went way up. And so suddenly credit cards that weren't used for delivery before are now. And so you actually have to pick that up from operations, go back to feature, make sure the feature data looks like it's correct, and then retrain the model with the new patterns so that you get the expected results. So like I said here, features are consumer ready, which really means model ready. And the data scientists spend time manipulating this, and these can be highly compute intensive, and they can be kind of very iterative, right? And then the model development is really just training that's done from the features that have been generated. And the main difference in that is you may go and run multiple algorithms to train different, like a dozen or 100 or whatever different models, and see which mathematical model fits your data the best after training. And then you may also tune some of the parameters of that model, the powers and some of the other features of that. So one of the other things here is models are trained with production data. It's never happens in software development that it shouldn't, where people are writing code and writing unit or integration tests with production data. They always use synthesized data or test data. Machine model data has to not only have all the legal values, it's got to have the same distribution when you're training. So your fake data has to have the exact same smell, sort of, as the production data. So you can anonymize your production data, but it's still production data. So that's something that's different. And typically, so the way I got into this is we were talking about a team wanted to use their build server to do their build and train environment. I actually feel like that's the wrong thing. So like CI/CD systems, like continuous integration systems, build systems, they're normally isolated from production data. We don't want somebody's random build script going out, reading prod data and sending it somewhere or doing something with it. Except when you're doing machine learning, then suddenly that's exactly what you want to do. You want to have some non-production system or some ops production system have access to potentially sensitive data so that it can see all of it so that it can run the training thing. In some ways, the CI/CD system wasn't really set up to be reading production data and process it. That's like a production job, right? So for the what really looks kind of funky about this, right? So there's the feature creation stage, and there's a workspace that needs to exist where machine learning or data scientists can manipulate the feature data. And they may loop around on this. And some of these transforms can take tens or hundreds of minutes, right? It depends how big the data is and how many transforms they do. So they're going to have to commit transforms. They're going to do tuning parameters around, trying to bin the data. So like if you're doing binning, you'll be changing the values of the bins. Oh, went from 42 to 44 short size, being a large, to 42 to 45, like if we were American sized. Well, if you're vanity, you know what? Never mind. We're not going to cover that one. The other way to do this is you can pick up feature data from other transforms. So you may have other ETL jobs, and that data is perfect, like it already exists. So feature data actually can come in two different ways, but there's a work stream around this, and there's a certain amount of time where compute and other resources will be tied up. When you're doing machine training, right? So on the training the model side, if you think you've got the right features, these can take tens or 10,000s of minutes. I worked somewhere when we were doing training, and they figured some of those models would take days to run, to train. And part of that was they weren't sure which model they wanted to use, so they had 10 different models, and they were going to train all 10 of them. And each one of those had a dozen hyperparameters. So they actually needed to do 10 times a dozen model training sessions to see what would happen, and those would be expensive. Another thing here in this section, so this normally is just general compute, right? When you do model training, because sometimes in machine models, you're going to start using specialized graphics processors. So that means you'd actually need a build environment that has access to GPUs or other Tesla, what do you call them? The tensor processors, right? So you may need custom, or FPGAs, right? You might need some field custom hardware here, and that's relatively unusual. So one build job may run on regular hardware, and another will need like a GPU cluster that you have to spin up to do the build and then spin it back down again. So this spell's kind of different. We really try and keep builds relatively short, like builds under 20 minutes. Good ones are under 10, some of them are an hour. And then we run the tests, and the tests usually could take maybe the deeper ones. You don't want it to run more than a couple hours, but that's still way shorter than a couple days, right? Or even a whole day or 10 hours. So the kind of the strain on build systems is a little different. So the machine model build and train environment, while it feels like DevOps, it's actually subtly different. And the only other thing here I'm showing you is the test cycle here, the way this works. So you take the feature data, you split it up. Some of the feature data is fed to the training cycle. You rerun the training cycle over and over, sweeping across models and sweeping across hyperparameters. Then you stage the models and the hyperparameters, and then you run the model with the part of the test data that you didn't use to train with. And if that looks good, you go to prod with it. But it turns out the way this really works also, we go and we create the features, we train the model, we test the model, we deploy the model. So that feels like, suddenly it looks like a CI/CD pipeline. It's very linear, but we know that these can be really long running and they can be complicated. And not only that, we need detailed versions of the results to show up in our dashboard, and we need custom hardware. The other thing that happens is you can have data come back from production that changed over time, and you actually need to update the features and retrain the model based on monitoring and drift in the production data. And you want this loop back to work. That's something we generally don't do in CI/CD systems. So that's something else that's different. That's it, really. I kind of had this notion of kind of what CI/CD looks like for prod and non-prod. In a lot of cases, machine learning doesn't really have a QA. They have like a weird set of environments where they plug this in. You essentially ran it with production data. It's not clear what QA means then, because as part of the training, you actually already tested it. So is there even a QA environment for models? Not really. There's not really like a UAT environment like we might have done traditionally in some cases. So what's the impact on CI/CD pipelines? If you use that for build and train, they're not designed for super long running jobs. They're normally isolated from production data, and we need production data. They typically don't have data steward permissions and other certain kinds of audit trails. The audit trails required for builds are pretty straightforward. What artifacts went in? What did I generate? Where did it go? And in like some artifactory or some other dumping ground registry. And then the build machines is also often tightly controlled. But here, the data scientists really want to do a lot of hands-on manipulation of the data. So they may need to do manipulation in some environment that's totally flexible and then promote that manipulation into a CI/CD environment where it gets run. Some places don't even like doing that. They like taking just what was generated by the data scientist because regenerating the features feels bad. It feels like you might regenerate them incorrectly. And it needs all this compute power, possibly hundreds of CPUs for a given run. That's something we don't do at all unless we're doing load testing or some kind of crush test against it. So the profile for machine learning build and train environments is different than the CI/CD profile. And I'm out of time.